Hello, this is Dr. Jeff Gosper. I'll be talking on the topic of from data to knowledge. But what we'll be doing is taking a little bit of a peek into the world of analytics. This is really at what we call a 10,000-foot view of the world. Not a lot of details, but a lot of touching on different areas that are of importance. It's somewhat chronological, but it also, so it ends with things which are quite modern. But the whole emphasis on today is how do we take data, turn that into information, and ultimately extract knowledge on that to make really, really good decisions in business and other places. In this slide, I have put a little bit about myself, Dr. Jeff Gosper. Started out doing science, did my undergraduate and postgraduate work at Sydney University, working in the area of experimental chemistry. But over the next few years, I got involved in research science, and also as a lecturer at Merrill University, I got very interested in visualization, dynamic behavior, and computing. And so I switched across to ultimately be into the computing areas by doing a master's. I got involved in a company. I'll talk a little bit about the work they did today called Tripos and how we did data merging and data analytics. I then came back to Australia as a research engineer and consultant on software architecture and component technology. Did some brief stint as a project manager for IT Reach, which is a telecommunications company, and then came back to education. So I started life as a head of school of information and communication technology, actually ended up as dean of the design college there, which included multimedia but included other things like graphic design, interior design, and actually fashion design. And for the last 10 years I've been the academic director of CSU, combining my knowledge of business, IT, and also looking after accounting. I want to start the presentation with really a question that you might think about, but it's basically a question you'll see when you go to invest or when you get a financial advisor. They'll often say, and in the small print, that, and I'll read this out, past performance is not a reliable indicator of future performance. So that's an interesting statement. That's actually an assertion. We'll talk a little bit about assertions as opposed to evidence-based materials, but we'll talk a little bit about that. Why is that the case? Well, yeah, there are lots of cases where data and systems are complex and unpredictable. The share market is rather unpredictable and complex. I wanted to look at some cases here where we've got some data, and we'll come back to that point about complex systems. But let's look at some simple systems, some simple data. Here's some data I generated. There are, I think, 10 observations over time, and it's showing some sort of measurable event. I've listed those, some sort of size and number. It doesn't matter what these are. These are in fact fictitious, but I wanted to, it does demonstrate the point I'm trying to make. You can look at, say, the trends. The trend here for this blue line, this series 1 is going up, series 2 is going down, series 3 is also going down, but there's a lot of wiggles, and the question is how confident you are in that answer. Well, if you just take the statistics and you just take the trend here, yeah, you can see this is going down. Well, I'm going to tell you that series 1 was put around with, it was developed with an increment in mind and a model which is behind that, which is going up. So that's actually found a trend. It's pretty good. This one itself is also going down. There was a model with some deviation going down. Interestingly, this one, even though it's going down, the data behind it was actually just a random number between 1 and 100. And so what you see now is that you've got to be very careful with data. You've got to be very careful about using these sorts of information without having proper statistics done, without having proper analysis done. In this particular one, you'd look at the correlation coefficient, you'd make judgment as to whether that was representative, was there enough data points, and so on and so forth, and that gets into statistics. But what I really wanted to point out is that it depends on the data you have as to whether or not you can make reliable predictions about the future. So as I mentioned, some systems are complex or even chaotic, which is a special type of system. I won't go into those, but basically the weather, economy, stock market prices, real estate prices may be and are very complex systems, and therefore they are very difficult to predict. There are a lot of other systems that aren't that chaotic, that are more consistent. You can track information and make predictions. We now have computers to be able to do this statistical analysis for us. And so I think this statement shouldn't be past performance is not a reliable indicator of future performance. I think it really should be past performance may not be a reliable indicator of future performance, and that obviously depends on the underlying data you have, the quality of that data, the information embedded in that data versus the number of sample sizes, the consistency, the variations, all that wonderful statistic stuff. So now we've looked at, data can have trends, and we can use data for predictions. What can we use and do predictions with? Well, here's another one. I want to bring this together and combine it into sort of management side of things. There was a quote a few years ago. It's an adage. It's all around the places. It's, believe it or not, it's actually taken from a potential misquote from many years ago. But people often say this: you can't manage what you don't measure. Or, if you can't measure it, you can't improve it. So these are both basically saying, as a manager, you've got to have real reliable data to know whether or not you're performing well. And if you don't have good reliable data, how can you manage that? I wouldn't go so far to say these are absolutely correct, but this is the way modern businesses are functioning. You'd rather base it on real data than just shooting from the hip, they often say. And what I really wanted to get towards is something like we're trying to get towards information that's useful in making predictions. And so I thought this particular quote from Peter Sondergaard, who was the CEO of Gardner Research, who does a lot of business-related research in information area and technologies and the impact on business. This is from about 2011. Information is the oil of the 21st century, and analytics is the combustion engine. I thought that was quite an interesting quote, and it's showing you that really analytics and the power of taking data, informing us in decisions, is really. So a lot of what I've been talking about is making good decisions based on good data. I just wanted to also drive that point home to say we are really looking at evidence-based decision making as much as we can. You don't always have the data. Sometimes you do have to make guesstimates. Sometimes you do have to estimate things. But what we want to get away from is unsubstantiated truths or dogma, and everybody says we have to do it this way, and that's the relationship, or that's what it is, and therefore it must be true. Well, I think, and as a scientist, I've been taught to always question those sort of things, but question what is the underlying data? Is there an alternate way of doing things to actually get better information? So another way of looking at that in the world of predictive analysis is to look at all the things that we could do. We could have facts, assertions, causations, conjectures. We can infer something. We can have something that's actually the truth, and we're trying to find that. We can speculate, so on and so forth. Of course, one way of doing things is to shoot from the hip, as I mentioned before, or it's to just blindly follow certain assertions that people make. Well, that's one way of doing things, but really what we want to get to point is to have really correlations, so we can do extrapolations. If you do science, you learn about hypothesis testing, and you actually will have proper data which supports or refutes particular ideas or particular theses. And so that's what it's all about. What we're really after is causation. We'll talk a little bit more about that. Obviously, by getting data, by using data, we want to be in this area and not just responding to people's opinion. What my boss says must be correct. Well, let's find out the data. And as a data scientist or as a experimental scientist, this is what I've been trained in. And this is what's happening in business. More and more people are looking to say, what does the data tell us? Because this is a course on statistics and relates to statistics is talk. I thought this was a really interesting thing, and we have to be very careful about cause and effect and correlation, and often what we're inferring here is correlations, and using correlations to predict the future doesn't necessarily mean that we have a underlying cause discovered. I thought this was a wonderful little cartoon on cause and effect, and I just have to read it because it's so smart, and we'll see whether you get it. This person says, I used to think correlation implied causation. Okay, correlation, like we saw before, the graph going up. Well, something must be causing that, whatever it is. Some deep cause in that, and if it's correlated, if two things are correlated, if the size of a person's foot is correlated to their height, well, maybe their height causes their foot to be bigger. But then I took a statistics class, and now I don't think that correlation implies causation. The other person standing next to them says, sounds like the class helped. And this is the response I really like. Well, maybe. So they've actually learnt something. They say just because you have correlation doesn't mean you have automatic causation, but it doesn't imply that you don't either. And obviously it's getting to causation can be very, very difficult. But a lot of analytics isn't necessarily about getting to the cause of something. If you can and have a model about the cause, that's fantastic. But you can still use the data if there are appropriate trends. That's the effect. If we can see what the effect is, we can model the effect, well, maybe we can figure out how to make our sales better, even if we don't quite know what the cause is. But ultimately, if you can go to the level of understanding cause, you've got a much better way of analysing something. So we started this from data to knowledge. What we're really talking about is having data, gaining information from that, understanding a model, our map of the world, but also to make decisions. That's what this is about. Some people put wisdom at the top. I don't really care for that too much. I'm more interested in about how do we make decisions. Okay, so we now have data. We've collected a lot of data, whatever that is. We need to do some sort of analyses. Well, we have all the statistical analysis and numerical analysis over the years, the centuries, the millennia that people have actually been doing statistical analysis. So we have various statistical methodologies, counts, means, modes, significant testing, etc., etc. More recently, we've moved towards the graphical and visual representation of data. So we've got graphs. There's all different types of graphs here. There's bar charts, scatter plots. These might be bar charts, or they could be histograms, distribution histograms, things like that. These are called candlestick plots or box plots, showing you the data spread. But there's other types of visualizations as well. This one's a map of the world, which has actually been distorted on the basis of the amount of organic agriculture taking place within that country, which is rather interesting. So there's graphical ways of looking at data. Once we have those graphical ways, once we have those statistical ways, we can use regression testing, we can use trying to do fittings, trying to look for outliers, what's special about these guys here, why are all these guys down here. We're looking for trends, interpolation, extrapolation, model fitting, and we've got lots and lots of mathematical techniques. Now, this is quite a complex area. Statisticians, mathematicians. Why do we want to do all this, and why do we want to learn about this, or do we have to learn all about this is the other interesting question. I'm going to talk a little bit about that. But what we want to do is learn from what we can measure. We're going to build some sort of model of the system. Now this is trying to imply some level of causation, so we get to know the system. Why do we want to do all this? Here it is. So we can play what-if games. What if I doubled the number of salespeople out there? Would we double the sales? What is the relationship? What evidence do we have? Because what we want to do is make predictions. So today I'm going to talk a little bit about infographics, but we're going to talk a little bit about how we do data decision support systems using data fusion and warehousing, dashboards, and I'm going to end up a little bit about big data analysis, predictive analytics, and looking at what we call unstructured data. So we'll look at these in turn. Infographics. Infographics is an interesting thing. I got interested in this a few years ago. What is the whole point of infographics? Infographics is about making complex information readily understandable by the viewer. And that's what it's really all about. So I've got here, infographics is used to present data, information, knowledge in an easy to understand form. That's the key. These are just some infographics I picked up about study. It is irrelevant what the subject is, but you can start to see there's graphs, there's icons, there's these interesting infographics models and things. We start to see these more and more in the modern world. Advertising uses them all the time, but we start to see them in newspapers, we start to see them all over the place. And we're starting to see to represent data, and data is everywhere. Increasingly, and we'll talk a lot more about this, increasingly there is more and more data coming towards us. Can we collect that data? Can we process that data? Can we use that data to understand the system and make it predictive? Well, the first step is you have to understand the size of the scale of the problem. Most reasonably large organizations have lots and lots of data storage areas, be it personal computers, be it spreadsheets, be it databases, a whole series of things. This is from some work we did 20 years ago when I was a consultant. So we were mapping out some of the data flows and where the data was held in an organization. This is a complex environment. It's not necessarily simple. Data is coming in from all forms. You can see things like SAP to handle their purchasing data. Siebel is a CRM, very, very popular CRM. There'd be accounts payable, accounts receivable. They're probably going into a database. As I said, all this information about shipping and all the rest is going into databases now. And it's becoming more and more available to us to actually do processing. Before we can process data, we have to get it together. So you can start to store it in relational databases, which is what we were just talking about there. So sales data can go into databases. The time something was sent out for delivery can go into a database, when it was received. The customer feedback can all go into relational databases. But to use this really well, you have to start bringing a lot of data from different areas together. Just say we're looking at students and students' performance. Why would we be interested? Well, we have to know who the agent is, what country they come from, what institution they studied at before, what was their scores, how they're performing now, what their attendance was. You can go on and on and on and make the data richer and richer, and you want to fuse that data together. And then you can ultimately produce data warehouses. I'll show you another slight variation on this, but data fusion is about bringing data together, linking it so it can be readily searched for information, or search for entries, or mined for information. Okay, so data warehouses are a particular type of databases that hold the Fuse integrated data. They are often used for reporting and analysis. So most large companies will now have a data warehouse. Study Group itself has a data warehouse called Cognos, where all the information about sales and a whole lot of information about the organization is going into it to make predictions about student numbers in the future. All medium to largest term companies are now looking towards data warehousing as a way of linking their data together to find out what's going on in their business, to understand things and to make good decisions. I wanted to talk about a little work that I worked on. Now, this is actually 20 years old now, would you believe? We worked on this 20 years ago, but it just was very modern work that we were doing in a very progressive company. We were developing a product called the metal layer. Now, the metal layer brought data together from various sources. It doesn't really matter what this is, and it doesn't really matter what this architecture means, but basically we're joining together all this information. Now, we just talked about data fusion, and we talked about data warehouses. That's one way you can do that. We were doing it on the fly. We were actually building these things on the fly from various information. And the whole idea is to bring that to the user in a form that's useful. This slide shows how the system fits together. Basically, there is lots of information stored. This was actually working with the pharmaceutical industry. They have what's called chemical structure information. They have property data about those chemicals. They would have assay. Assay data basically means how's the biological testing? Was it active? Did it kill a particular bacterium? Was it effective in limiting cancer? This is called high throughput screening. It's the modern way of doing screening in pharmaceutical industries, and a whole lot of other things. But basically, these are a whole lot of different information. But what links these, interestingly, is the chemical structure, because the chemical structure it has a name, it has properties, it will be assessed, it has data, and so we could link that based on the chemical structure. So we put our what we call our meta layer over the top of it. We were able to bring that to people's desktops, and this was what the desktop looked at the time. You could look at a structure, you could select the structure, and you can come and select something. The system would then determine what you wanted to do, what information you wanted to go and do, go back through all this system and bring relevant data together. And the part I was working on particularly was the visualization. These are some graphs that I brought into the system. We'll talk more about hierarchical and partitioning graphs. But you're familiar with spreadsheets and graphs, and so we were doing this. This is actually 20 years old, but we were dynamically, we were the leaders in the area of this, and we had multiple pharmaceutical industries or companies interested in this technology. This was with Tripos Inc. It actually doesn't exist anymore, which is interesting. It was on the NASDAQ, but a few years after I left, it folded. No connection. But now we have all these statistical methodologies, mathematical methodologies, and all the rest of it. Now, do you have to be an expert in maths and stats to do this? Well, yes, you do. To understand how to process data, how to put data together, how to fuse it, how to clean it, fuse it, mine it. That is an expert, and that's why we're starting to see the rise of the data analyst. And I've just picked out here from a recent what's called Hayes Quarterly Review about, this is employment, about what's happening to employment. You can read this yourself in your leisure, but you'll start to see analyst, data analyst, using data analysts who can mine through massive data for informative insights and trends. And so what's interesting here is there's a whole new realm of job market for people. Now, this is basically people usually pretty strong mathematics skills, but not necessarily. You can have basic skills in mathematics and statistics, but you've got to know how your data works. The whole idea here is to model the data. That's what the analysis is about, to actually produce information. Model the data, of course, you can bring that to the desktop like I did for Tripos, or the data analyst can then decide these are great ways of presenting this information, and they can bring that to the desktop. These are what reports are done out of warehouses. But nowadays what we're seeing is real-time data feeding these particular dashboards. Now, these are called dashboards. Now, there's different types of widgets, and these are just infographic widgets that show information. This is just showing, you can show a number here, but this is then showing, you can say a number between 1 and 10, but what they've decided is this number here is 7 is the area where it goes into the problem region. So not only do you have a scale here, you have someone's interpretation about where the green zone is, the orange zone, and the danger zone, the red zone. So what you'll find in dashboards is often color coding to mean what's good, what's bad, are we doing well relative to where we should be, so on and so forth. That's the sort of thing you'll see up here in a spreadsheet type, a grid. These ones, these cells, whatever this corresponds to, is doing well, but this one isn't. So this is the types of things that are being set with the data analyst setting what's called metrics, ways of measuring things. After we've fused or fused and mined, we then set up thresholds and metrics to say what is good, can we measure it, what do we want to measure. These are often processed data, not raw data. So this means that these dashboards are being designed by experts. They're being designed by the analysts. Why? so that you get the benefit. You as the manager, you as the salesperson, you as the person who is responsible for a division, know what's happening with your business. The goal in dashboards these days is to have these in real time, or as close to real time as possible. There's a lot of data warehousing that takes sort of overnight builds. So the next morning the manager will come in and see this is the data of where we are versus the rest of the world, and this is where we should be. But all that's been built prior using statistics, mathematical modeling, threshold metrics by an analyst. I just want to touch on a few different points in this slide. One is, why are we doing all this? Why are we doing this analysis? Why are we doing these dashboards? At the end of the day, the dream is to have a return on investment, to increase our profitability, to increase our competitive advantage. We've got data coming all the way around us now every day. We've got big data, lots of data coming in from different sources now. I wanted to read out one particular trend that was discussed in a document from the Australian government. It was what's called the Australian Future Workforce Committee for the Economic Development of Australia. This was looking at what is the impact today on employment and what's going to happen in the future, and they concluded that cloud services, big data, the Internet of Things, artificial intelligence, robotics are rapidly reaching a point where they will be, or they have, widespread impact on the economy. So what we're seeing is the rise of the analyst. What we're seeing is people doing their work in a different way. We're seeing new companies form. My daughter has just got a job as a software engineer at a company that does market research in real time of customers and monitors customer behavior. So there's a lot going on. So there's lots going on, well, really lots going on. And here is a slice of data from 1 minute on the internet. You can look at that and what it means, but it's huge amounts of data, and maybe that can be looked at as well. And I thought this was an interesting one, that it is true that Merrill Lynch is in charge of the Bank of America CEO. He said a few years ago, somewhere about 80 to 90% of all potential useful or usable business information may originate in unstructured form. Because everything we've talked about so far is data that could be collected, the time of a dispatch, the cost of something, the number of items, the number of things that have used, how fast people produce things, how our production line's going, whatever, call centers, whatever. That's numeric and structured data. You can put it into a database, and you can even form that into fuse it into a data warehouse and extract it. But if most of the information we have comes from other sources, what do we need to do about that? So I just wanted to focus on where the world's heading over the last few years, and that's in the area of unstructured data. Social media, there we go, social media down there, unstructured data. This is what I call the growth of published opinion, but that opinion can mean something. What are people saying about my product? Is it good? Is it bad? Are they likely to buy things again? So there's interesting stuff there. We'll just touch on that. And of course, the Internet of Things that was mentioned just a minute ago, that's basically connecting devices to the Internet, providing day in, day out information and data. You know, your fridge is now going to be monitoring its temperature of its different regions, and you can look at that on your mobile phone in the future if that becomes of relevance. It's that data is flowing through. So how are we going to use this data? Some of it will be structured, a lot of it will be unstructured, but how do we make use of it? I thought this one, we touched on this before, and I just put that in there again because it's so important. Analytics is the combustion engine that makes modern businesses function and improve in their competitiveness. Okay, so the solution. Well, this is starting to use different types of statistics, not just the traditional statistics that we talked about before, which is numerical statistics, which is counts and means and regression and all that wonderful things. A lot of the way that text is analysed is through text mining, is through machine learning and artificial intelligence. And often there is, and I'm not an expert at this field by any means, but there's a whole lot of ways that is growing. That's an active research area. Also, for a lot of data, one really good way of analysing the data that I didn't talk about before so much is decision trees. And decision trees are a particularly powerful method for making data accessible to the manager. So you can sort of see, is that person going to be a buyer again? Once you build a decision tree based on the information you have, you can do what-if games. You can put, okay, if I offered this to another company, where are they likely to be? Oh, they're actually not likely to be a buyer because this is what it is. Put in another company, another person, they come up here and say, oh, okay, they'd buy our product. So building decision trees is a really interesting area. So the whole idea is to come up with predictive models. That's decision trees is one, and statistics is another. Machine learning is another. It's harder to understand the models that machine learning algorithms come up with. They can often correlate things and give you answers and give you predictions, but they can't often tell you how they did it. It's very hard extracting the reason for things out of machine learning algorithms. But solid metrics. What do we regard as a really positive sales figure? If that figure is dropping to a certain thing, where do we have that red, green, and orange points? They're what we call the metrics. They're our indicators that we're going to follow to say something's good, bad, or indifferent. Okay, and so you can start to see here the increasing importance of the data analyst in this big area of growing complex information, more of it, more structured, more unstructured. I don't want to go into it, but the whole area of text analysis and text mining is a huge area of research across the world, and I think we've only just really started to see the first things coming out of that. So the first things that come out of that is what's called natural language processing. What does that mean? Well, being able to speak in normal language, Siri, Katana. Wolfram Alpha is a website you can go to, and that has natural language querying in math, stats, and also will find facts for you. You can actually ask Wolfram Alpha, what's the fifth largest city in Japan, and it will figure out what you said using this natural language processing, and then figure out, well, you're asking for the fifth largest city. It works out what fifth means, works out what largest means. It'll give you the list and give you an answer. So Wolfram Alpha's been working on natural language querying, mainly for maths and stats. It had some wonderful ways of doing mathematics for you, but it's been around for a while. It's an open system. You can test it out yourself. Siri and Katana, you can basically say, find me the restaurant closest to me, and it understands it. Some other parts of natural language processing is in sentiment analysis. What are my customers? What are people saying about us? This is really interesting. And indeed, I was talking about my daughter has started. That's what the company that she works for does. And they look at sentiment analysis, and they do a lot of things in those areas. What is a little bit harder, and there's active work being done, is what's called semantics. And semantics is the meaning of something. So, I ate spaghetti with chopsticks. You can parse it, you can understand it, all the rest of it. But what is the meaning of that? And what does it really mean? And so sentiment analysis, you've got to be very careful. If someone said something like, this is an excellent example of a piece of software that is full of bugs. If you read the first part of that, this is an excellent example of software, you think that's positive. But then when you read the whole sentence, it's full of bugs, undermines everything. And so you've got the underlying meaning there is a negative, whereas simple sentiment analysis would have that as a positive. So sentiment and semantics are going hand in hand, but the whole idea is, what's the meaning of something when someone's saying something? And so that's quite an interesting area, because ultimately to get information from the data, which is what people say, and that's your data, what do they really mean? What are they saying about us? What does that mean in the future? Is an important area, and that's an active area of research. Just a couple of other quick things. I just wanted to point to you that numbers and text aren't the only things that are mined. We started looking at audio mining a number of years ago, and we now have Shazam that can identify songs. YouTube, if you upload something with some background music, it already finds you, the owner of that is Sonny, and these are the things that will happen to you. So they're doing audio searching, and that's pretty well done now with songs across the internet. Face recognition is becoming very big. Google's image search and other types of image search is one way of doing it. So searching images, searching sound, and I want to talk a little bit about Microsoft's auto image tagging, which just alludes to where things are today. Here's an example of a Google search. Now, interestingly, Google enabled the image searching back in 2001. It actually changed its algorithm in 2012 because of the growth of pornography on the internet, but I won't go into that. If you do a search on that image on Google, it basically says, my best guess that this is Wave Rock. That's in Western Australia. And here's the sites it's found, and here are the actual images it found, the exact image I pulled these from. Face recognition, a little bit more complex than image recognition because faces aren't always in the same angle, all the rest of it. This is a goal of many security companies, of shopping centres. Ultimately, a lot of places want to have individual identification. We're getting there at the moment. Technologies out there which are pretty decent. So here's an example of one. I use BetaFace, which is an open website that you can go to yourself. I put this image in. It said, this person, who is this? It says this person is likely to be 41 years old, 60% confident in that. They have a beard, I'm confident in that. He's got a neutral expression, they're male. He's not wearing glasses, he has a moustache. Well, 84% confident he has a moustache. Well, I think he has a moustache, but anyway. His race is white, 100% confident with that. Okay, so who is it? Put it through the engine. It found, and this particular one looks at celebrities and Wikipedia. This one found a few different matches, but the closest match is this one. It had to pivot the image slightly. So it's rotated that image to line it up. It says it's likely to be this fellow, 69% confident. And then there's some other people that it might be, but less confident. So the only green one here is this one, and that is Keanu Reeves. So it found it. So at the moment, this is only searching faces which are sort of face on. Directly, it's a head and shoulders shot. It's only searching limited databases. This particular one is searching for Wikipedia, celebrities across the internet. It doesn't search the whole internet now, but that's going to come. There were some discussions about that happening out of a Russian company that could, with about 70% accuracy, identify a person from their shot and their Facebook shot. Haven't seen that yet. It hasn't been released, but it is coming. But that's face shots, and it is coming. The technology. Of course, we had this headline a few years. Google Glass can now search faces in real time. This was by facial network company that was coming along and tagging into Google Glasses. Well, Google Glasses didn't turn out to be particularly positive, and I think this was a claim. It turned out to be not substantiated. So at this point in time, this is actually not a particularly easy thing to do, particularly when the faces are far away. We've seen if they're up close and they're under controlled conditions, it is, but there's lots of things to do with shadow. A lot of current research is in the area of aimed to getting people recognition at a distance, so where they're partially obscured faces, they're shadows, they're not facing you completely, whatever. What they're actually doing, some researchers at CSU, new professor at CSU, and other places around the world, are actually using face and gait. Now, gait is the way people walk to actually identify people, particularly in airports, for security reasons. So this is an active area of research, quite interesting. Across where are some other research at the moment. This was some work done by IBM. You can read it yourself, but basically you put in an image, and not only does it find the image, it tries to write a little bit of text. So it mines the information that's on those pages, trying to understand what the key piece of information is. And as it says here, these are not just about where it's found. It's not exactly a description of the content. It contains interesting facts, and they're doing some algorithms that mines the web to find these interesting text snippets with associated images. So put an image and finds not only the image on the web, it'll find and give you a summary. So that's there already. They've already got that technology. Haven't quite released it anything yet, but it is coming. What does it all mean? And before I say thanks, what's it all mean? Just to draw in a summary, that we have data coming in from lots and lots and lots of sources. Some of it's structured, some of it's unstructured. Unstructured from the web, social media, structured from devices, information systems. We can mine those, we can search those, you can make predictions, you can set up dashboards based on those. With some unstructured data or more complex data like face images of faces, like the way people walk, that's a lot more complicated and we're not quite there yet. But the whole idea is, with the information we do have, a lot of powerful statistical methods, mathematical modeling, with the use of infographics we can build these dashboards, and the dashboards allow the managers of areas, the people who want to know what the data but don't necessarily want to do the data analysis on the back end, to actually make decisions and make better informed decisions. And that was what this whole talk about, is to use data to make informed decisions, trying to look for those correlations, trying to look for the evidence-based information rather than just saying, well, I consider this or we believe this. Well, that's all well and good, but if we have information, can we use it? I just will end on this cartoon. I won't even necessarily read it out to you, but I thought down here was an interesting little infographic, and I'd be interested to know what you thought about today's short whirlwind tour of the world of data knowledge, informatics, and decision support. Thank you.